And hello all, it is Mr. Callan here to walk you through scatter plots from Chapter 9, Lesson 1. Before we get to there, just a couple reminders. We're not going to do math review. We'll take care of that in coming days. And more on Khan Academy later, but you should be by Friday at 90% from early math, 90% for arithmetic, and 66% for pre-algebra. This is a great opportunity to catch up, folks. You could spend an hour or more working on Khan Academy and all that you need to do. Meanwhile, some of us have a retest to take, while others of us are working on getting through this big 25-point quiz and retaking that quiz. So just remember, Mr. Callan's doing all that he can to help you out. It's time for you to put in that extra work, and let's work together as a team. All right, let's get back to business, please. And so we start with our objective today. We will construct, build, create scatter plots, as well as use scatter plots to make conjectures, guesses, predictions for the future. Predictions like, okay, can we draw a line of best fit? And where would we be at about 8 games? Or even better, where would we be at 20 games? Now, we're going to eventually use this to make an equation. Equation being a prediction of, oh, it starts at about 0 and it goes up, let's just say 15 points every 4 games, something like that. But can we use that equation to make a guess? How about not just 20 games? How about 200 games? Imagine making a graph all the way to 200. But we will be able to use to analyze data from scatter plots, make conjectures about the future from those scatter plots. All right, some notes you may have found in your agenda. I'm going to open up the agenda real quick. I hope you have it bookmarked and use it often. In the agenda, I'm going to attach the video right here. We got notes right here. All you got to do is open it up. When you pop it up on the screen, you can press open with Cami. It might, as soon as you start writing, say, wait a second, you don't own this document, something to the effect you need to make a copy of your document. Feel free to do so at this time. Go ahead and pause the video. Come on back when you're ready to take notes. Now for the notes, I don't care if you use the text box option and write in these boxes, or if you just open this up, grab your finger, grab a stylus, and start writing. That is up to you. So let's begin with a 3-2-1 format for notes. 3 most important ideas, 2 mistakes to avoid, and 1 question that you might still have. Now we're going to talk first about some things that we've discussed before. One of the most important ideas of scatter plots, understand what is the dependent variable, what is the independent variable. Now the dependent variable is what you're measuring and therefore goes on the vertical or the y-axis. Naturally, that would mean the independent variable would go on the x-axis. Now, if you recall yesterday with our passing the book activity, what we were measuring was the time in seconds, but the time depended on how many students were actually passing the book. All right, now, speaking of passing the book, we found that the time increased as there were more and more students. Therefore, we would call that a positive association, a positive relationship. Meanwhile, you might find that snow on your roof will decrease as the temperature increases. We would call that a negative relationship. Just think about it. Positive divided by positive is a positive, but a negative divided by a positive is a negative. All right. Sometimes the data, which we found, looked to be a straight line. In that particular case, we would call that a linear relationship or a linear positive relationship with our situation yesterday. But let's be honest, not at all times would that happen. You may find sometimes that it goes in a non-linear relationship. In that case, we would draw a curve to best fit the data. All right, let's fill in some more blanks, shall we? When the dots are very close together, we would call that a strong relationship, compared to if the dots are more spread out. In that case, there might be a relationship, but we would say that as a weaker relationship. Okay, what do we call points that are way out there? Well, those would be outliers. Remember, Mr. Callan, klutz that he is, dropped the book at one point. So that data exists, but doesn't really belong. Meanwhile, if you find points that are packed together, we call those clusters of data values. Remember, please, the nice part about videos, you may pause at any time, go back, write your notes, come back. You could even split your screen, have Mr. Callan on the left side of your screen talking while you're filling out your notes on the right side, if it's big enough, that is. All right, 2 mistakes to avoid. The y-axis is the dependent, or what we're measuring. The x-axis is the independent, or what we get to choose or pick. We chose how many students lined up. We cannot choose the time that it took us to pass the book. Now, choosing a good scale is going to be important. Yes, you obviously need to get the biggest number, but you don't want to have all the points on like a third of the graph. So here's what you're trying to avoid. Well, yeah, you got all the points on there, but you meanwhile have wasted the top 2/3 of your graph. So you would want to pick a nice scale so that yes, you get to all the points, but you find that you've used most of the graph, and it just will make a clearer depiction. All right, I'm going to ask you to pause the video at this time. One question you have about scatter plots, and you're welcome to take a sneak peek down here before I talk about it. One question you have, pause the video, come on back when you're ready. All right, so let's delve a little deeper into what kind of relationships or associations there are. And just a note on that, in the 15 years I've been teaching, we used to call this correlation, then it was called association. Some people simply say relationship. You can see correlation and relationship both have the same root word, relate, in it. And an associate is somebody you relate to. It might not be a friend, but it's a colleague. It's somebody that's in your group. So if you find that the items, the variables, increase together, as x increases, so too does y increase, that naturally would be called a positive association. Think time increases as the number of students passing the book increases. Think points increase as more games are played. Meanwhile, if you find that there is a negative association involved, you'll find that one increases while the other decreases. So as missing assignments increase, grade would decrease. Last but not least, there are times when there's no association at all. There's no pattern. Remember the essential question we've been asking for the last couple weeks. Is there a relationship between two variables, and how can we describe it? If I'm looking around my classroom at the number of desks and I'm looking outside at the amount of snowfall, it's not like snowfall changes the number of desks in my room, or vice versa. It's not like by adding or subtracting desks in my room that it changes the amount of snowfall on the ground. There is no pattern between those two variables. All right, so what if there is a positive or a negative association? Can we describe it further? Well, sure. If the data points lie pretty close together in what appears to be a straight line or array, that's a linear relationship. That is a linear association. We found that to be the case when we were passing the book. One class, was about a half of a second each student. The other class was about 3/4 of a second each student, but both classes we found it to be a pretty linear relationship. On the other hand, sometimes a line would not fit the data best. You see that? Nope. You see that? Nope. But could we draw a curve to describe it? And watch as those lines disappear. And watch this. Yeah, that's pretty good. I would even call that a positive, strong, nonlinear association. So linear line, nonlinear curve. Ladies and gents, once again, you may pause the video, fill out the rest of your notes, come on back when you're ready, and then we'll start up guided practice from the homework assignment. All right, so scatter plots is the assignment. If you need to, go on back to the online agenda, and you'll find this worksheet here. Once again, feel free to open it up with Cami. When you do so, if you start to type or write on it, it might say something to the effect of, wait a second, you don't own this document. Do you want to make a copy? And your answer is, well, yeah, I want to make my own copy. And you may use the typing function or writing function once again, although when it comes to other things, you'll definitely want to use the drawing function to plot your points. All right, so let's begin. Let's go through the directions together. Interpret the scatter plot. Interpret, tell what it means. Now, there's a number of different ways to interpret. So first of all, we're going to look at its variable association. That's a fancy way of saying, is it positive, is it negative, or is there none? And yes, ladies and gents, we do need to explain. Otherwise, people could randomly pick one and get it right a third of the time. Linear association. So this is a big old if. Notice that word if. If there is an association, we're going to then identify, okay, is it linear? Is it nonlinear? Last but not least, we're going to describe other patterns that we might see. Look for clusters, look for outliers. Let's begin with number one. So I'm looking here, it appears that we're measuring the amount of water in a bathtub, although there is that keyword draining from the bathtub. And we're comparing that to the time in minutes. Now we're going to first ask, is there a relationship? If so, what is it? Well, it surely would appear, it doesn't want to work with my mouse. It surely would appear that these go down together. In other words, I'm going to go ahead and say negative relationship. Let's try that again so we keep the yellow or red. So I'm going to say there is a negative association between the water and the time. In fact, water in the tub blank as time blank. I'm going to often use words like increase, decrease, but you can make your own sentence. It appears that water in the tub decreases, goes down, drains out as the time passes by, or as I said, I'll use these words often. Negative association, water in the tub decreases as time increases. Now, I do believe that we could draw a decently strong line through this. In fact, if I do that, I want you to notice how closely all those data points are. And if they're close, then I'm going to even use that word strong linear association. As for this, I don't know about you, but for clusters, I don't see any. And outliers, I also don't see any points that appear not to fit. So you may write none, you may write NA for not applicable. And so now we have described the relationship between water from the bathtub and the time as it passes by. Again, you can pause, you can rewind, you can fast forward, go for it. Here we go with the next one, ladies and gents. Here we're comparing the number of books read to a person's shoe size. Whoa, look at how spread out those dots are. I don't know about you. There is no association here that I'm seeing. In other words, the number of books read, how about we say, is not affected by a person's shoe size. You could say is not changed by a person's shoe size. You could say does not seem to have a pattern when compared to someone's shoe size. Therefore, We are not in need of doing anything else for this problem. If there's no association, you're not going to even talk about if it's a linear or nonlinear association because there is none. I don't know about you. I see no clusters. And there are no outliers because there's no pattern to the data and then weird numbers that lie way out there where nothing fits. Onward to number 3. Pause the video if you would like. Draw a line or curve through those points, and then we will commence with discussing if there is an association and what patterns we see. Go ahead and pause the video. Come on back when you're ready. All right. I first thought, well, maybe I could draw a line through there, but I want you to notice how all those points seem pretty far away. And then I looked again and I said, well, that appears to be a decent curve through it. Because I can draw a curve that seems to very well fit the line, provide a good fit, I want to ask myself, what's happening to the test scores as the time goes by? Well, test scores decrease. There's a negative association here. What are we measuring? Test scores. What is it comparing to? TV time. What's happening to test scores? Test scores are going down. Test scores are decrease as TV time increases. Put that in your own words, folks. Test scores go down as people watch more TV. There you hear the words down for negative and more for positive. Meanwhile, we talked about a nonlinear association because we drew a pretty good curve through it. And those points seem awfully close to that curve. I don't see any clusters, so I'm going to write NA or none. But outliers, I think you would all agree that there does appear to be a point. Look, somebody watches a whole lot of TV and their test score is still pretty good, but that doesn't really belong with the data. So I'm going to go ahead and I'm going to write, there is a cluster, there is one outlier, one found at, you can list the coordinates of the point or you could interpret what they mean. In other words, someone watches about 4.5 hours of TV and still scores a pretty high test score of 38. Notice that does not say percent, it's just a 38. So that's pretty good. All right, this one, all on your own. First things first, decide if there is a positive, a negative, or no association and explain. Then come back and say, if there is an association, what would fit it best, a line or a curve? And it would be strong or weak. Last but not least, do you see any clusters? Do you see any outliers? Pause your video and come on back when you're ready. All right, folks, in this case, number 4, I don't know about you, but I see a positive association. How do I know that? Because it would appear that points scored increases with more games. Total points increase as games increase. Now, I'm going to call that weak because if I drew a line through there, forgive me if it's not terribly straight, I do see a few points that are more spread out, although I'm going to put a question mark here and I'm going to wait for some students to argue that point when we come back together. Last but not least, I do see a cluster of points in between 2 and 4 games played. You see there's 7 points really close together. That, ladies and gents, is what you would call a cluster. And this is how you would describe it, between 2 and 4 games or between maybe 6 and 15 points. No outliers that I could see. So let's move on and talk about number 5. Read on your own. Come on back when you're ready. What are we measuring? We are measuring the amount of emails that Vincent receives. What might that depend upon? Well, let's find out. In terms of the number of days, 6 is the largest number we got to go to. You can go by I've seen some people try halves, 1, 2, 3, 4. Notice that doesn't get up to 6. So we're going to have to go by wholes. Now, in terms of the number of emails, we got to get to 21. So twos wouldn't work. If you went by twos, you wouldn't fit in that last point. You may do threes or fours. Threes would work quite nicely. That just gets a little tougher to graph. I'm actually going to do threes this time, and I might not do threes ever again. The reason why I'm not a big fan of threes is because when you go to graph points, you have to realize there's 1, 2, and then 3, 4, 5, and then 6, 7, 8, and then 9. But that being said, many of you getting some very strong, good number sense. So if you want to go by threes, don't worry about it. Go for it. All right, first point, day one, 16 emails. So I'm going to go ahead a little above 15. It'll be 60. Day two is 21 emails. Day three is going to be 3. If you'd like to, pause the video, finish up the rest of your points, come on back and check. All right, so part A, check. Part B, interpret. Is there an association? Well, I don't know about you, but I do not personally see any association. I don't see it positive. It doesn't look like emails increase as the days increase. I don't see negative. Some people have argued with me there, but I just think these points are too spread out. So when it comes to interpreting, I'm going to go ahead and I'm going to say, well, I don't so much see anything here. There is no association between emails and days. And we're going to go with our Oreo here, complete sentences, dig a little deeper. There's no association because according to what I'm seeing, I just don't see any relationship. I don't see the number of days affecting the emails. All right, that it does it for the first page. Now I'm going to take one moment to talk about number 4. People have asked in the past, Mr. Cowan, which is the dependent variable? Does the width change if the water speed changes or vice versa? Does the water speed change as the width changes? What depends upon what? So I had some quick videos here some quick pictures here for you. These are actually pictures of the Mississippi River. I want you to notice anytime you see the Mississippi River, it looks pretty slow going. But I want you to look at the width of that. There are places in the Mississippi, I do believe, I hope I'm not mistaken, that are a mile wide. Imagine a bridge going across that being a mile wide. The Mississippi River at most points is pretty slow going. Now I want you to look at any pictures of rapids. And I want you to compare the width of the rapids to the width of the Mississippi River at this point. Now, here's what you need to know. When a river gets thinner, it's got the same amount of water being pushed down. All that water upstream is pushing it downstream. But you have less and less space for those water molecules to go. So there's going to be more and more energy, more molecules bouncing off each other. And if you hear those words, more energy, you can see that that would translate into faster speed. In other words, the speed of the water depends how wide the river is going, how wide the river is at that particular point. So I just wanted to help you out with that backside in knowing that the water speed in kilometers per hour is going to depend upon the river width. In this case, those measurements are made in meters. All right, ladies and gents, that's all I have. Go ahead and continue on with your homework. Khan Academy for one class and this assignment for the other class. That means I expect 30 minutes or more on Khan Academy, as well as this assignment completed. I'll check this tomorrow as I walk around. I'll just look at your video screens. One last shot at the front side answers if you're interested, and then tomorrow I will check the back side. That's what I got, ladies and gents. Take care. Let's grow. See ya.